Alright, here's something that I don't think is emphasized quite enough in elementary physics problems, namely the force due to gravity that we use often while we're at the surface of the Earth. We write it as F is equal to little mg, like that, little m, little g, force due to gravity. And then we use this in combination with other forces to write Newton's second law, which is F net is equal to ma, for example. But the tendency is to think of little g as acceleration, when in fact the force due to gravity between two masses, let's say this is mass m1 and this is mass little m, and this is the distance between them, r, little r, like that. It's actually equal to the gravitational constant times the mass of one object times the mass of the second object divided by the square of the distance between the two objects. So this can also be written as little m times g times big M over r squared, like that. Well, this part right here, if little r is equal to the radius of the Earth, meaning we're at the surface, then this is equal to little m times g times big M over r squared, where that's the radius of the Earth, and it's this that's equal to little g. In other words, little g is just shorthand for this. And if you plug in the numbers, little g is equal to, I'm going to use SI units here, 6.67 times 10 to the minus 11, that's the universal gravitational constant, times the mass of the Earth, which is 5.98 times 10 to the 24th kilograms approximately, and divide that by the radius of the Earth, which is approximately 6.378 times 10 to the 6th meters, square that, and that works out to be about 9.81 meters per second squared. And that's what little g is at the surface of the Earth. But what I'm trying to emphasize here is that that's part of the gravitational force. It's not actually the acceleration produced by the gravitational force in most problems. If there's other forces acting, the net force is equal to the gravitational force and the other forces acting on some mass.